Welcome to another video on my BeagleBoard embedded system with Ubuntu Linux right here, programmed in Python, attached to an HDMI monitor which I have to use to boot it, and for the rest it is sleeping. A serial connection for Minicom to do the basic things to boot, and then most importantly a USB cable right here which leads to a USB hub which is down here with a network cable, and the Python program runs through this fischertechnik global interface which controls in totally this fischertechnik roller track, starting up high, coming down 2 tracks, the older track and the newer one, which I had to provide with some conveyor belts in order to guide and drag the balls to its original point. Which brings me to the actual focus, which is right here, because last time I had to improvise a piece of track. None of them were short enough, and I want to do something similar to right here, but at the end of the attempt last time I noticed that the magnet was not going properly, so I have to do something about that, and that's the focus of this time for now. So let's see how I can get it running. Alright, and then before starting off, this is once again the VNC desktop. Then this is the Minicom serial cable connection. I also have the schematics. So this is everything of the rubber interface, switches to control which way the marbles or the balls go, and then a few motors. And then one camera pointed right now at the BeagleBoard, but I wanted to show more of the construction, and then the other one which shows actually where I want to focus on. So let me point the other camera to where I actually want to go, which is here. So this is the other, the opposite perspective, kind of. Not entirely, but yeah, sufficient. Diagnosis interface needed for some work if I only want to test a motor or a switch or whatever. My Python program, and here to run it. But let's now focus on this, because this needs some fixation, literally fixation. Because if I lift this one, and I have to be careful doing that, removing, that is, which shows to be not that easy. And why isn't it easy? Not even quite sure. The point is that the lower axis is not fixed, so I have to remove this part in order to get there. So let's try again. And with this camera you can see what I've done. Look right here. That's not yet tested, by the way. Connection between the part where the motor is coming from, or yeah, one of the, yeah, it's actually from the motor to the other side of the axle. And I do hope that this is working. So I need to reconnect the motor. Somehow the wire is coming off. Time it again. I think that the wire is a little bit too tight. Anyway, which wire is it anyway? It's motor motor 1, I think. Open, yes, and then bring this down a little. Bring this up. Can I watch it? Now I should be able to watch it. So, yeah. And it gets stuck. Why does it get stuck? Ah! Wait. It gets stuck between or with balls. Okay. Okay, I need to put 2 balls at the place. Now it is getting stuck again, but why? That's interesting. The axle is now running freely, so why is it running freely anyway? That means that I have to put the lower axle a little bit down, I think. And where's the problem now again? Yeah, at the same place. Okay. Still not perfect. Alright, so now actually it was about fine-tuning with the height of the axis, the axle, and the speed. So looking actually at the code, it's all speed 2. Well, not everything, but one is set to 2. So that already was the case. And this motor, which is motor 3 actually, motor 3 is 1. Really. But when I put this down to 1, will this work? Let's hope so. Okay, so yet another try. No coda. Just some balls here. Okay, let me select the camera. Some balls here. What will be happening? Nothing much, I'm afraid. Unless there is enough weight not to push them away. And that's exactly what's happening. So, some more balls. And then I come to the other problem. I think it's too horizontal and it should, just like here, be in a slight angle of 7.5 degrees. And how to accomplish that? The only thing that I would have to do is for the middle part to construct it like it. And that would suffice, I think. Because now the balls are pushed back by the magnets and seldomly picked up as should be. But will that work? That's a big question, because I also had a problem to put this at the right height. So it won't be that easy. Alright, and I've put right at the bottom of this part, constructed part, a 7.5 degree piece. And then it followed, then it made a real obstacle here, so I put another supporting piece here directly underneath. So, question is, what happens now? Speed 1. Does it actually take any of these balls off? Well, right now, no. Actually, yes, it did properly. And yes, all 4. But I do need something here somehow. But this looks like a solution. Let's try again. 4 balls. Oh, this one has completely gone off. Not the intention, obviously. And yes, it just takes 2 balls, which is quite nice. And you may hear the thunder that's going on with the rainfall. Luckily outside. Anyway, that is the reconstruction of this time. Time to stop this one, close, and run the entire thing for the time remaining, I think. One ball coming off somehow. Yep. Another ball coming off. So let me just drop it somewhere. And the place is up high. So 3 balls in my hand. And 3 balls down here. Let me grab them. Where else do I have balls running freely now? As far as I can see, nowhere. So this video had as focus this chain with this solution right here. It works, but as happened before, next video will have another focus. So thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. And those can be done per email or under the video. You can support me via Patreon, becoming a patron and have your name mentioned, becoming a co-producer. You can also support me by donating via PayPal or Wired, Wired being IBAN. This is obviously going to be continued. For now, have a nice day. Take care of yourself. Bye bye.